So these are the in-class notes of the discussion of the time that it takes to search in a hash table when we use chaining in the worst case versus the average case. So let's say we have some hash table and we want to search for a key k, so we have already some entries in the hash table. So the first thing we do is we determine the hash value, so that might be I, and then we look into slot I, and there might be elements there. And in the worst case, so in the case where I want to, where k is not in the hash table, I will go through the whole list in slot I. Now if we have n entries in our hash table, so in this example n is 7, then the worst that can happen is that all of this is actually in the slot I, so everything's here, and then searching indeed takes linear time. So the worst case is linear. But now if we assume that the elements are placed uniformly at random in the hash table, then we get a different setting, at least for the average case. So let's say we have m cells, let's say in this example m is 7 also, so we have the scenario where m is 7 and n is 7. Now if the elements are distributed somewhat uniformly, let's say we might get something like this, then on average the number of elements that I'm going to look at is the average list length. So if m is 7 and n is 7, the average list length, as you also see in this example, is simply 1. Just to have a different example, if we would have 14 entries, then the average list length would be 14 divided by 7, so that would be 2. So that is actually simply, the average list length simply corresponds to the load factor. So that tells us how expensive searching is. So searching on average is of order 1 plus alpha, so 1 for finding the slot and then alpha to go through all of the entries.